This is the last in the list, the another operation with del. It's a curl. So we have discussed about the gradient, divergence, and this is curl. So gradient is the del of a vector, and divergent is a dot product of a del dot a vector field, and curl is del cross a vector field. V may be anything. V may be a flow of air flow, V may be a fluid flow, V may be a direction of the lines of force, electric field or magnetic field. So the V may be any vector field. So just the curl just give you an idea about how much vector tend to rotate around a point. How much the vector is rotating around a point. So you will get a clear idea about del dot V. If del dot of a vector field, del dot a vector field equal to 0, it means that the vector field is irrotational. The vector field is not rotating at any point. So we can conclude with this operation whether the vector field is rotating or not, because some cases we know that vector field will bend, because in a magnetic field and electric field the lines of forces start from plus to minus, and some point it need to bend. Okay, there is no straight lines of forces. And here you can see that the vector field is rotating, and here and some point here you can see that it is clockwise, it is rotation, rotation is clockwise. But if you here it is also it's a clockwise. And now see this point. If this is the vector field F, and if you take the curl of F here at this point, if it is a clockwise, then it is less than 0. If the curl of a vector field, here I am taking vector field F, if curl of a vector field is less than 0, it indicating that the vector field is rotating in a clockwise direction. If the curl of a vector field is greater than 0, it indicating that the vector field is rotating in an anti-clockwise direction. This is the clockwise, this is anti-clockwise direction. So if a curl of a vector is 0, it indicating that the vector is not rotating. And here you can see the best example of all the three. And look at this figure here. It is clockwise direction. So as per the rule, the notation, the curl of F is less than 0. That means it is a clockwise. And here you can see that it is also a clockwise. But at this point you can see that there is some vector tends to rotate in anti-clockwise direction, this point. And if you look at this point, see, like this here, this is an anti-clockwise direction. And if you take a vector, the curl of a vector field at this point, you will probably get a positive answer. And similarly, see here, this point, there is an anti-clockwise direction here, see. So there also the same result, the curl of a vector field is greater than 0. So it gives you a clear idea about what is the direction, what is the direction of the vector field, whether it is rotating or whether it is rotating in a clockwise direction or anti-clockwise direction. So probably the del cross operator will give you best idea about the rotational characteristics of any vector field. Now let us see that the mathematical representation of del of a vector. Let us take a vector A. We can represent A as ax plus ay and unit vector ay plus az and unit vector az. Then the del operator is, so dou x of ax, dou y of ay, dou z of az. And if you take the cross product of del and a vector, then the cross product answer is, you take in the matrix form, a 3×3 matrix form. In the first row is unit vectors and second row is the partial differentiation with respect to x, with respect to y and with respect to z, and the third row is the coefficient of a vector, ax, ay and az. And then you need to take the determinant of this matrix. So this